Hey guys, um, it's all happening. I've had a crappy day, like you got no idea. Um, what's this piece that looks like a moustache? There you go. Everyone's wondering what that is. That's just where I had the door of the onshape open to in the last half hour. Um, yeah, what I'm doing. Gosh, this is not really the answer, is it? Um, might turn this off. That might be better. Maybe. We're putting a gold line, pinstripe between there and there. Is actually can't see it on that side. It's just not much good showing it to you. Um, I don't know if you can see it on that side. Maybe you can see the gold, and on the back so far. This is a masking template or a lining template for the front. So looking at it, piece goes around there. The one I had printed out to cut the masking tape doesn't quite work because it doesn't clear the headlights. Because the headlights are way too high. If I did this again, headlights would be down another 5 mil, 6 mil. But we're going to live with that. So this is sort of starting to feel like it's ready for some clear. There's a bit more work to it, but that's what I'm working on at the moment tonight. It's not the thing I should be working on, but it's what I'm doing just for a little bit. Anyway, we've got some other jobs, right? Matt PJ or Tea and Biscuits. We know him in my other live stream and also in my Discord. He set a little task for tonight, and Mark set a little task for tonight. We're going to have a look at this too. So steam engine part. We'll go back here. I'll click on shape here and go back to the menu. When you open on shape, anyone who's new here or anyone who knows all about it, anyone who needs a refresher, when you open onshape, you get this screen here. Now, these over the last many years, there are probably, if we have a look how long, there are parts in here that were modified in 2020 last time. There were parts in here that were modified in 2017. Can you believe that? 2015. When I started using onshape for projects. Some of them sort of got made and some of them are actually never really survived. Some of this stuff I'd like to have another go at, and eventually I might, but it's how long I've been messing with onshape. Anyway, end up with this screen, and this will be blank where it says owned by me up here, or your files. It mightn't be in here if you're just starting into onshape the first time. But if we click create and then create a document, we get this pop-up screen here that says untitled document. I've got a bit of a cough. Sorry guys, you might have to put up with that. I'm sorry about that. We're going to call this Matt's nameplate. And we create a public document, and that'll take us straight into the first Part Studio 1 it says down here. You can rename that. And it's probably good practice to rename that. You right click on it and rename. And just type in what you want to call it. Is that how we're spelling it? Let's have a look here. That's how we're calling it. So, Labyrinth is the name of the engine, and we'll need a nameplate for a miniature engine. Now we sent some drawings. Let's see how we go just with the default text on the first one. So we'll start a sketch and select the front sketch plane. We can select it like that just by clicking on that one. It lights up. See, as you come over it, or we can click up here where it says front, and it does the same thing. And up here is the text window. We can drag out some text, something like that. And Labyrinth, that's the name of the engine. Now, I don't know what style to even do it or where to even start with this. He did have sort of a style. It's a remote. Let's keep going. Oh my gosh, I've got a bit of a cough. I could nearly have the week off. In bed, it'd be very nice. Some of these don't have the bold option. The font that he sent me, the pictures had a larger bottom on the bead and on the top, so we might go with something like that. I mean, that's just open sans. It's really not terrible. That's terrible. This is for a model steam engine, or a miniature steam engine. So it wants to be a little bit sympathetic with the rest of it. Oswald, what's that? Oswald might be. Let's start with Oswald. There we go. A second screen unmute. Oh, don't let us take you away from your work, TMB. This is probably not a bad sort of somewhere near. It's probably not a bad starting point. Now, he did send some measurements too of the lettering on his engine, and the B is about 20 mil wide. That's may not be helpful. And the lettering is, oh my gosh, it's about 1 inch tall. So we could probably do that way. If we put a measurement on here, it'll, that's sort of where we're at now. Can't really stretch this out any, and it's looking a bit too condensed for me. So what I'm going to do is just extrude that. We'll go up here to where it says extrude. Shift E does the same job if you're looking for a shortcut. I reckon that it wants to extrude about 7 millimeters. Probably from the back of there. No, I don't think we want to do it that way. Let's extrude it 3 millimeters. And I think we're going to put a little bit of a draft on it to make it easy to cast. If we select the angle of the draft, and we want, I reckon 5's probably not bad. Click that. That gives us a little bit of draft that way, see? And a little bit of draft this way, which makes it easier to get out of the mold if we're casting it. So I'm looking at that and thinking that's not looking terrible. But we do a sound check. I guess everyone can hear me. That's actually quite nice. I don't mind that. Does it want spacing or does it want... if we select all those objects, like so, and we go up here and click transform, we have an option here to scale it. I'll skid this up here so it's not over the top of it. And we unclick the scale uniformity. We don't really want to scale the Y. Liam, you're right. The fact that onshape does, oh, welcome to the stream, but doesn't have kerning as a crime. Make a ticket about it. I think that this feature gets used a lot more than people think it does. So I would really like to see. So join me and write a ticket about it, because see if we can get that changed. Scaling it's probably, this is the way to do it, is to pull it in out. I mean, that looks quite sweet, but if we do this, see, what do we got here? Something's trying. We need a mate connector. So if we just make the center point, vertex of origin, make sure that's actually front. We can press N for normal. If that's not quite right, we can press N. Does that? It doesn't in that situation. But that gives us some idea what it's going to look like stretched out a little bit more. I'm not sure if it wants to. Let's click OK and see how it looks. Too far? What do we think? That's a good idea, Lamb. Give it a bit of space around the words. That probably doesn't look terrible. Is it any difficult? Is it difficult to read? It might be a little bit far. We can go back and we can edit this one rather than do it again. .3 might be a bit far. Let's have a look. Interesting. I'm going to have a look at the picture that he sent. It's sort of looking something like, but not terrible. I'm going to try it back the other way. So we go 0.9. See, that's a bit sort of skinny. That's getting a bit hard to read, I think. What's everyone think? I like it better back the way it was. I think that's where we're going to be. That looks good. Are there any constraints on the plaque size? No. He wants to scale it to match. So he wants to print one out and see how it looks on the engine. And if it looks a bit big, scale it back down, scale it back up, whatever. And maybe get one cast. But I think it's better spaced out. Liam's right. Funny sort of a word. I reckon that looks all right. I don't like the L. I think they're a little bit. I think we're going to do it like this. If someone knows a better way of doing it. That's probably not terrible like that. I think that looks all right. We could put a bit more space between them and drag them out a bit, but I don't think it needs it. We're going to work with that. So we've got letters. They're sitting on the front plane there. So if we do another sketch, also on the front plane, say click the front plane. I don't like this much. I think that's a bit ordinary here. We haven't really. This is another problem with onshape's lettering, is it hasn't really put it in the center, or it doesn't have it doesn't click to center as well as it should, I don't think. Let's transform these again and just get them in the right spot. Now, there's several ways we could do this. We could do it by make connectors. We could do it by X and Y. I think that's the center there. So the easiest way probably is just to skid this along until that locks on the center there. Is it going to? What's the story there? Do we have... I've turned that off at some point, haven't I? Because that's not locking on the center. Let's see if it does it that way. Not really. Why is that doing that? Where the center is, so I can't really do it with mate connectors. I call that close enough, but for some reason that's not locking on the center. So if someone knows why that is, I'm open to some learning there. I think that's where you've got to be. But anyway, there we go. Let's do another sketch. We already did another sketch, so we'll open sketch 2. And we'll find here a center point rectangle. You see what's done that? Sketch 2 was created before the transform 2 that we did to move it. So when we open this sketch, what happens is that it works on the parts in the state that they are before this one actually achieved. If we drag this one down here and then we open it, then nothing moves because it's in the same spot. System compatibility is a problem, so probably that means usually that I've got to update my browser. That hasn't happened. Hey, Kevin. We just press escape so that we don't have any measurements on this. What we're going to use is use the use button. We're going to use that one and that one, which are constrained with the use button. That's taken off the other drawing or the other sketch. Probably off the part because this sketch is hidden. And we put some dimensions to get this somewhere near the same. There's probably a much easier way to do this. I'm not sure that's actually achieving what I want it to achieve. Because that doesn't work, does it? Looking at the measurements though, they're about the same, so I'm just going to undo that. One's 4.83 and one's 4.82, so that'll do us. It's about even. I think I suite's probably good enough. The measurement there is, looking at that, I think we'll ignore that. And another square on here. Like so. 176, 166 plus 173 minus 166 is about 6 mil. We can probably mention that this way. And for some reason it's done that. Just to mention this. $175, and we can either select both those and put a line out here that says 43. That looks pretty good. Now, casting plates with square corners are a bit of a nuisance because they're very difficult to cast here. Hey, Matt. Very difficult to cast with this square corner in here. You get away with it, but a bit tricky. You could put a round corner here and then put a round corner on the outside. So let's put a fillet here. Use the fillet tool. Click these through here. It's given us a measurement here and a direction. If we right click or left click that, the same as it says, a little mouse with the green button, let's call this 3 mil. And this one too. Now, I reckon it wants round corners on it. I'm not sure about that. Probably doesn't. Looking at it, the screw here is probably what it needs to hold it in place. You put a hole here. And probably a hole here, something like that. Or we could put the other thing that we could do there's probably room for a screw in each corner here if there's round corners. We might leave it at that. We've got that. Now let's extrude that. And we went, what did we go, 3 mil before? Have it sticking out the same, 3 mil. Probably a bit of draft on it, just the same. There's another really stupid I think I'd lift that out of it. I think I'd be able to lift that out of a mold. Could probably fix it a little bit. We'll have a look at it. Another stupid thing Onshape does while we're on that subject is that it sets the draft up for a pattern the wrong way around, I believe. Now, If we do another extrusion, and highlight this one, and I reckon it wants to be 5 millimeters, and change the direction. That gives us a nice solid plate that'll be easy to pour. And draft angle on it. And that draft angle's the right way around for that one. And add this and use the merge scope of all the parts on this side. So we can select all of them by doing that. No, we've got to do that. There we go. Wrong way around. Click OK. That gives us one solid plate. That looks all right. It's a good start. There's enough on there to machine it down. It should cast pretty nicely. It's a bit of definition so you can fill the back up with plenty of paint and stuff. I'm wondering how, if we put a fillet on here, probably it's going to look all right. Trouble is with this, and I think this has changed. Someone tell me if I'm wrong, but I think that this has changed because not all that long ago you could select a whole lot of fillets, not in a line. Now you've got to do one at a time. Someone needs to invent a batch fillet tool. That's what it wants. That looks not terrible. And so on. What do we think? I'd like to see a round corner all the way around it, but it's a bit of a task because what you're going to find is that in some places this is going to get too close. That's what I'm leading to. If you do that, what you find is that when you go to do it with this one, and we'll do this other letter while we're here, Remember to turn tangent propagation on. We've got problems. So I guess that's why I've never had much luck doing that. Anyway, we might just make all the inside corners round. Like such. Someone might know a workaround this. I did post in the onshape group, and I know there's people watching from there. So people have got more different skill sets to what I've got. So because that's what you use all the time. So it's kind of helpful to have those people watching. They're really appreciating you guys that come from there. Let's see if this will fill it, because this is going to be a problem area. And it did. Look at that. Look at us go. That's not terrible. So I'm going to do this one. There. And we might do this one. And this one. Rather than click back on there, we just go Shift F, which is not as easy as it looks. And enter would probably work as well too, but we'll keep clicking that green button. We'll zoom that one in. This one. I'm going to cough. Sorry, guys. And this one. And this one. And this one. We're getting very close to finished. Zoom this in. Wrong button. Press the wrong button here. Should pick that up for me. I'm testing it out. And the same over here. We'll pull this over here. 2 more to go. It's this one. And this one. So there we go. Doesn't look like a bad plate, actually. Quite like that. So, job's done. There's a lot of fillets that there should be an easier way to tidy up. They get in the way a bit. What we can do is put them in a folder. So job's done. That's a little bit tidier. It's all those things. So if we select that, it shows all of them. Now, what else does it need? That should print. It's quite a solid nameplate. That's about 10 mil thick. Let's have a look at the left side of it. It's about the same. Anyway, should be nice. Job's done. Anyway, so that's one job done. Let's go back here to onshape and have a talk about the next one. Next job is this. Mart, it absolutely would. I'm going to talk to him about that, though. He's busy at the moment. He's sort of in the chat now, but we'll talk about that. I think a little detent, if we go back and have a look at that, it's a valid point. Little detent off each end would probably be really nice. Make them a bit thicker. But looking at this, so a boss here and a here for a screw. Depends where he wants to put it. I'm going to let him print one out and see what he thinks it likes. We can make a boss this way quite easily on the inside to put a screw here and a screw here. Or we could make these semicircular in here to put a screw in each corner. Or we could put one on the outside, or we could put 4 on the outside. There's all sorts of things we could do. I'm going to let him print one out, see what he thinks about it, and what needs to be actually changed. So that's where we're going with that. Anyway, probably, Kevin, it's going to be probably brass to match the rest of the engine plates. But he's got a 3-inch scale barrel, agricultural engine. Yeah, I'm sort of thinking that too, but we'll see what he, excuse me, we'll see what he actually says. Let him print it out and see what it actually looks like. We can change it from there. Now, another job we got. doesn't need an 8 in it. Hang about. Drugs. No measuring cup or anything. That's terrible, isn't it? But good stuff. That's got to be better. Now, Mark sent this. Well, I picked it up on Sunday. He was up at the foundry. And I took the job on. Probably shouldn't have. I've got plenty else to do. But this is for Mark's Shed Talk. These are guides. Bronze guides. For the ends of the valve guides, basically. There's 2 of them. They look like this. Right? One valve guide would do, but they're made in separate parts so that you can slide these out without taking the valve rod out if you need to replace them. So they've just got 2 bolts. Undo the nuts, and you can slide these out, replace them, and have the job done. So most of the glands and things are designed so that on a Fowler roller, these are off his roller, but most of them are designed so that you can actually replace them without pulling the engine completely to bits and putting it back together, which is a good thing, because that makes for a big job. I know the water pump glands are designed so that you don't have to take the water pump off to do it. Things like that. Anyway, these are worn. Now, they've got oil grooves in the middle there, see? And it's got an oil hole in the top, which operates into the oil reservoir with a wool and wire with worsted wool on it as a wick. But need new ones cast because they're quite worn. This is quite oversized. And not only that, his valve guides are a bit undersized because he's cleaned them up. Little bit. So my thoughts on these is rather than cast them as one piece and then worry about splitting that length with a hacksaw or slitting saw or whatever and thinking that that's a recipe for disaster. If we cast these in 2 pieces and machine both sides, and then either A, make a collar to go over it to hold it all in place, which may or may not be a good idea while you machine it, or B, probably a better idea, is just to get the propane gas out and run a bit of soft solder on them when they're together. A bit of soft solder in here to hold them together, and then you can warm them up and get rid of that later. So they need to be cast. They need to be quite a bit smaller on the inside. Still with the core, they don't want to be solid. So you don't want to machine all that out because A, it's a waste of brass, and B, it's a waste of time, and C, if you're doing a casting, you get shrinkage. If you've got this huge mass here and you're trying to run brass in here, what's going to happen is that you're going to end up with slump in the casting because this will shrink at a much greater rate. Something that's an inch thick is going to shrink at a much greater rate, and call it a different rate to, say, the gating. So you're going to end up with a casting that's not going to fill up, basically, if you make it thicker. So the answer is to cast them in 2 bits, I think, and put a core, something sort of, for example, core about that diameter in them, right, in each half. So basically mold them, but make a piece to fit in here with a shape well, sort of the same shape as this bottle, but probably the same shape as a bit of PVC pipe or a bit of cardboard tube or something like that we're going to use. A good trick I find for core boxes is a couple of rings and just a piece of aluminium sheet, like a Coke can sheet, or such, wrapped around in a circle, and then the rings slipped over them, and that makes a really good core box, because when you take the rings off, it all springs apart and everything comes out nicely. So that's probably the answer. And they need to be a bit bigger on the outside here, and they need a machining allowance probably on the outside here as well. Now, this outside here, probably the easiest way to do this is run around this with half a roll of masking tape around the outside, cut it with an X-Acto knife down each side, give them a coat of filler, and sand the corners up, and that's probably plenty good enough, because they don't need a lot on them. The more you put on them, the more you're going to machine off, and they just need enough so that they shrink in place. And we know that they're not worn on the outside, so if they clean up to what they are here, that'll be plenty good enough. So I was thinking to 3D print a piece to go in the inside with maybe an inch core in it, and then we set in the sand with the core imprint, and then make a core to fit in there, so that we drop that in afterwards. And you've got a hole in there so that you don't have to machine quite as much out of it. This end here, probably make a plate to just super glue on there for a bit, or even a piece of cardboard or something on it to do, but probably make a 3D printed plate, a couple of mil thick, to super glue on there, and super glue this piece in here, give them a coat of paint and fill them up with filler, and you should have a pretty good pattern, I think. So that's where we're at. Looking at this, got trusty vernier out. None of this fancy electronic stuff around here, although I'm getting to the point that the fancy electronic stuff, or at least a dialed calipers, sounds like a really good idea. Because I've got to do this. So that's 39 millimeters that way. Looking at this, it's only 38 the other way, which we can work with. The length here is 5 inches long, so we need 5 inches. We're going to work in imperial and metric here on this one. Plus about, I think if we made them 5 inches and then made a piece to go on the outside, I think it'd be the best. So let's have a look here. If we draw this hole for a start, sketch on the front here, front plane, same as we've done. Drop this down. This is the ellipse function, like so. Now, if we millimeters that way, is that right? That steel rule's no good because it's all in black and white freedom units. So yeah, it's worn the way you would expect it to be. If we move this over here, we can put this in first, or we can move over this one before we press enter, and it gives you the option to put that in. So 38 millimeters across. and then the other one is 39. It's not far out, but it's an ellipse. I reckon it wants an inch core in it. We're probably going to put that on afterwards. And we need to extrude this out. So let's go 105 inches. 5 inches. So we can select inches there and have 5 inches. $127 millimeters, whatever you want to call it. Depth 5 inches. It's rounded that down because it's not putting the decimal place in there, but there we go. That's the right way up. Now, the best way to do this, if we use this function here, which is split, this little box with the split through it, if we click that, I'm not sure we've used this on live stream. It's given us parts and surfaces and curves to split, so we click that, part 1, entity to split with, and we're going to select that, and then top plane, which is through the center, and that splits it into 2 pieces. So now we've got down here, we've got part 1 and part 2, top and bottom. Now I think both these parts are probably going to be exactly the same, so we could hide part 2. So we don't get mixed up. I'm going to rename that. Inside, I'm going to call that, we can get rid of the caps lock too. Now, if we sketch this, I think the best way to do it was probably put another sketch on the front plane, and we'll find a circle up here, center point circle on there. See, if we made that 25 mil, doesn't matter much because we're going to machine it out, and we extrude that, let's go 5.5 inches. Select inches. There we go. But not quite right, because what we need to do, we're going to edit that and put a second end position on it, and we'll make this one 0.5. It's 12.7, but 0.5 inches. It's 12.7. There we go. And what that gives us is a core print. So probably doesn't need to be quite that long, but we can put a core in there the same size as that in the sand before we put the top on, and it's going to leave a nice depression in there. I think that's probably the easy way to do it, rather than try and leave the sand sticking up a bit and try and remove that from the sand and discover that the piece is going to fall out. We just make a separate core out of sodium silicate to drop in there. So if we print that, that should give us the piece to do that. Now there's a flange on there that needs to be 2 millimeters thick. So let's just hide this too, so there's no bits actually showing. And we'll put this piece on the same job, on the same part studio. Sketch on the front plane. This is an oval. Looking at this. Can you hear me? Probably not. 110.3. If we make an ellipse, see how close this is. An ellipse. So we know that's 110.3 that way. And the other way, just looking at it, pretty close to 58. So we'll go 58. The center holes, or the hole centers on this, probably look at the drawing if we wanted to really get fussy about it. But I'm guessing they're a nominal size if we're going to go there too. Because it's Fowler. And the nominal size there that I'm measuring is 3 inches. The holes are have a look here. It's got to be a bit oversized, I think. But close enough to 9/16 diameter, 562 thou. So if we put another sketch on here, if we press this one, which is for a line, or we can tip L, we press the Q key, which gives us a construction line. And we come up here, 1.5 inches. Enter. 38.1 it says. And we put a hole here, a center point circle on there, which is got to be 9/16 for easy, sir. 9/16 inch. We can do the same there. It's 14.288 millimeters. So there we go. We can draw several ways you can do this. Probably the easiest and quickest way is just to select midpoint line. Start here. Go to there. Except that's not quite right. Midpoint line. Start on the center. Go to there. Escape. And the scissors, which is M. Trim knob. There we go. So we can extrude this. Two millimeters. That's what we said, wasn't it? Not quite right. Because while that's the right shape, it hasn't got a place for the go over the core cutout. Several ways we could do that. We could put an actual cutout in the core, in the bottom piece. That's a bit more messing around, to be honest. The easiest way probably is just to modify sketch 3. go back and edit this and put a 25mm circle in here. And scissors or M again. Trim this one, this one. This one. And there we've got that. If we turn on this part here, we'll find that we've got an interference. So let's change this. We'll go back here, edit that extrusion. Click this. This is what we need, just to tick that like that. Opposite direction. We've got two pieces. So what we've got there is, if you're following along carefully, a piece that'll go inside this with a matching hole, hopefully, fill up the inside and leave a place for a core print for a core in the center. And we can put a dab of super glue on that. It'll come out later if we need to. And put the flange on the outside with another dab of super glue, bit of fill around it, and that'll be excellent. Now, this flange, this hole really needs to be filled up. And this needs a little bit of work, because it would be very nice if this face here had a taper on it or some draft on it, so that when we pulled it out of the mold, it actually lifted out nicely. So, how do you do that? We'll get rid of this again. And we'll extrude this. We'll change this extrusion again. We'll make this, I reckon, 4mm. And we'll sketch on this plane here, which is the right-hand side plane. We'll click on that. And we've got a feature here. There's a couple of ways to do this, but I'm just going to go with a line, I think. It doesn't matter very much about this. If we just put a line through there, and this is rough, but if we draw a box around like that, then extrude that, click symmetrical so that it extrudes halfway each way, and we'll make it, what do we say, 60mm wide. It covers all of it. And we click remove, and the merge scope of part 3. What we've got is a tapered piece. Look at that. So we turn this back on. That fixes that problem. And that should be really good. Does the back want to be tapered too? Makes it a bit difficult to machine, to be honest. We could put some filler in it. I'm feeling like that might be the way to do it. Now, this hole here needs to be filled up. Right? And this flange is what did that clean up to? I'm guessing that's a nominal size too, because it's Fowler. 10mm is close enough. But we've already cut this off here, so we want it to match on the outside. So what we need is to put another extrusion. We turn on sketch 3. I turn this back on with a little eye there so that you can see the sketch. Regions to extrude. Haven't turned that on yet. There we go. we can extrude this 10 mil. And the second end position on the other end. 4 mil, that's how thick it was, I think. Right, so that fills up the hole nicely. Now it's going to have a ridge there, so we want somewhere to put some filler in it. So I'm going to put a chamfer on there. Doesn't want to be anything like that big. There we go. But this hasn't cut this off here. So the secret to this is to move this one down to there. Fix the problem. So what that's done, and changing our order of operations, has moved this so that from just operating on this, it's actually extruded past our last two operations there, and it's given us a nice smooth surface. So there's the two parts. If we print them, there's a pretty good chance that they'll fit inside there, and we can make a core to match, and we should have a pretty good casting that's repeatable and good. Does it need a piece on the inside? Maybe. Don't know. Good question. Might be easy to put a bit of filler on it. Don't know. Why not go back and add to the original extrusion? Really good question. It's got to be done separately because it comes to a different piece. We can just extrude the same hole, but if we only extrude it 4 millimeters, we only add this up. If you extrude both ways, then the whole thing's going to extrude. So what I've done is just put a new one in and put it in the right place in the order of operations, and then that fixes it. So there we go. Job's done. So that's a pretty productive evening, really. We've got a couple of jobs done. I need to 3D print this one. I'm going to actually, I'll print one up and I'll make a core box and fit it all up and take it up, and someone else can cast it for Mark. I haven't got enough time. Sorry, Mark. I might get up there and have a bit of a go at it if we run it up there. There's quite a amount of gunmetal that's actually mine, so probably it's going to come out of that. The bronze, and they'll come up all right. So that's that. So with any luck and a good downwind, those two pieces should fit together very nicely. And fit on the original piece. There is a hole here that we need to block up. Right. So probably the best way to do that, we can't make it as part of this piece, because if we print two of them, what you're going to find is that the other piece hasn't got the hole in it. But this hole here is 1.5 inches from the end, and it looks to be about 3/8 hole. We could do this. If we put a sketch on the top plane, like so, select a line and Q for construction line, and from the origin point there, we come down here 1.5 inches, and so we're going to select that there, so that's that. Press enter, and center point circle. 3/8. We can do it that way. We could also go 0.375 inches. And press enter. And that gives us a dot in the right spot. Now, if we extrude that sketch, because this is a construction line, that won't extrude, but this one will, and it'll poke up there. If we click remove, and the other way, it puts a hole in there between, if we're looking at that, between this center line here and there. It's not a bad thing, really. It's not a really a difficult thing. It won't hurt. Job's done. And we can make, if we sketch on the bottom of that surface, face of extrude 6, we can do that. We'll find the center there, because that'll tell us that. Move out here so there's no constraints, and we'll go 3/8. That doesn't work. You've got to go IN, and it pops up that little window. And we can extrude that. It's a new piece. So what we've got there is a pin to put in one of them if we need to fill up this hole. Now, that's a bit irrelevant, because if we wrap this with tape, you won't see this hole. So the advantage of having that is that when we cast it, what you've got is a flat surface to mark this hole, which is kind of really nice, to be honest. Probably something that's worth doing. So that's my thought process behind that. Now, this is almost impossible to 3D print. That's the last job, I guess. If we turn off part 3, which we're gonna call this one the flange, outside flange. We'll rename that. And we'll call part 4 the pin. Bit of wooden dowel is probably easier than printing that pin. If you just had a bit of 3/8 dowel, cut it to the right length. It's probably a really good way to do it, or a bit of aluminium rod or something. It's plenty good enough. If you make it a bit shorter, you can tap it to length so that it sits down nicely on the surface of this. So this part 2 we don't need. So if we delete that, it says delete composite parts. Part 2 we want to delete. And we've got the 3 parts. Now, 3D printing this is going to be fun, because looking at it, there's no flat surface. If we print it up here, we're going to have to support one end there and print it quite tall. It is quite tall, and it's a bit unstable, and it's going to take forever, because it's printing it standing up. There's quite a lot of perimeter compared to the infill, whereas printing it laying down, I think there's probably more infill than perimeter, so that's a little bit easier. So what we need to do, where we split this here, if we drag this down here, to the end, it doesn't work. We drag it there, that will work. However, it doesn't quite work right because we've lost this part under here as well. We're going to just Control Z that a couple of times. And this piece, we're going to do another split. I think is probably the easiest way. Just split this piece again, parts and surfaces. Keep both sides. Entity to split with is this. And what that gives us is an extra part. So you've got this bottom part. That'll do. You're right onto this, Peter. So what we've done, we've got those two pieces there. We can line them up by eye probably pretty good. We turn the sketch off again. So we've got this piece and we've got this piece to go on top of it. And we can print both halves fairly quickly and without a lot of worry about whether it's going to topple over or anything else. And you're also going to, if you clearly leave this hole here, you're going to have a nice surface here, a nice surface up the ends and all that sort of stuff. Whereas if you sit this up on its end like so, what you're going to find is that you've got an ugly end here where it was supported, and this hole's not going to be particularly round because of the layers in it. The mirror of the image. Best way to do this, right, if we close that off so you can't see this bit, just put a sketch on this one. The yellow line there so you know it's in the center. And we can extrude that. Make a couple of pins to line it up. Now that doesn't make it any easier to print like that because you can't sit it down actually on the bed of the printer. So what I'm going to do is remove the pieces, and we'll make them. Oh my gosh, 6mm deep, and that gives us 2 holes there. So we know we get them the right way around. It's not important in this instance, but that's why I haven't put them symmetrical. If we turn this one off, merge scope this one and this one, if we make it symmetrical, select this one as well, and we make these say 12mm because we're going half each way. remove from these two parts. We click that. Then if we turn this one off or hide it, we've got two holes in that one, and we've got two matching holes in that one. So we can put a couple of dowel pins in them. We can print a couple of plastic pins. That's easy, quick job. Line it all up, make it all work. So there we go. That's that job done. I think that's where we need to be. We can print this piece. Print this piece. Make it a bit easier to see. Got two pieces there that stick together. We've got a flange there that sits on it, and we can print that quite easily. And we've got a pin in one of them. So there we go. That's the piece for that. Job's done. So that's probably nearly it for tonight. We've done pretty well. We've got those two jobs pretty well going. And that's the piece to actually go, oh my gosh, I've dropped that. It's under the bed. Never find it again. Because I'm in my bedroom here. I don't know if you noticed that. But that's the piece to go inside that to give us the clearance for the hole, with a 25mm hole in the centre. And block up all the holes so that they're machinable. And give us a bit of taper on that flange so we can pull it out. So there we go. That'll be cast. So what happens is that we turn this the wrong way up. Probably can't really way up. Is there an easy way to look at it this way up? Yeah, there we go. Except I didn't. Press N for normal. What we'll have is a sodium silicate core, the same diameter and length as this a water glass sand, sodium silicate, same length as this cylinder here, and the same diameter. And that's quite a hard piece. So the sand is mixed with sodium silicate, or water glass solution, and then that's cured with CO2, which makes that go hard. And you're left with a core that's quite durable, really. It will break if you put a bit of effort into it, but it's quite a durable sand core. Now, the impression that you leave in the sand looks something like this. This piece, with the piece with the flange actually in place on it, and we use our imagination for that. And less this cutout for this core. So what we do is pour that from the top here. I'm thinking pour it from the top and sit this in here. Then we haven't got this piece of sand in here, this shape hanging down, that is likely to fall off when the brass swirls in around there and basically give you sand inclusions in a failed casting, because that's going to be nicely supported over. That's why the overhang on each end is to support it outside the mould. When the piece is removed, this piece and the brass piece, when they're all maxed together, and when they're removed, what you'll find is that you've got a nice cavity in there that's got a core that sits over the top nicely, that is going to be solid and secure. And you can pour in there and pour down there, and hopefully the brass should run in there and down there, and you'll have a hole in the center that makes it easy to machine. And all you've got to do is machine these off nice and soft solder them together, the two pieces. and bore them and machine them, really. As far as machining them, I'm not sure how you machine the outside. That's a bit of a mystery. You might have to rethink this, because I would soft solder them together. If it was me, post casting, I would soft solder the two pieces together. I'd mount this in the 4-jaw, nice and square on the 4-jaw. I would make a wooden plug, like a piece of broom handle or something, piece of dowel, with a taper on it that taps in here with a centre hole in it. When I get this all set up nice in the chuck, I would tap this and I'd put a centre in it, and then I'd machine this across here, the length across here, and from there you can take the plug out, take it out of the 4-jaw, and you can set this back up nicely on this surface that's machined, and bore it and face the ends. So hope that's helpful, Mark. That's where we're at. We've dribbled on for long enough. So thanks for everyone that tuned in. I don't feel like I'm a teacher of this of any sort, but hopefully it helps someone get a little bit of an idea of the procedures behind how things are done, and the quick and what I find is the quick and easiest way to do things, and a little bit familiar with the software, so you can get in and have a bit of a go and mess around with it, and see what you end up with. And that's the end game, really, is to get in there and play with it and discover that it's not as scary as it looks. So, it's, to be honest, I don't know if it even needs a wire in it. It wouldn't hurt, but that's Peter, that's a good thought, and quite often you make a core with a wire down the centre, but I think that's going to be self-supporting. It's quite a solid piece of sand. I've done things of similar proportions and not really ever had a problem with it. I don't think it'll break, unless you drop it. I don't think that'll break. Should be all right. Anyway, I'm going to call this, guys. We've been an hour and a half. Really appreciate you all tuning in. There's 6 people watching, apparently. Anyone who sort of had a talk in the chat, that's awesome. Really like to interact and like to get feedback, and especially if you've got a bit more experience than me, or you do things a different way. It's really cool to see that. So that's where we're at with that. Thanks, guys. I'm out. I've got a live stream in the workshop tomorrow. I don't know if there's anything really to share. I have done a few little jobs, not very much, to be honest. It's a bit sort of sketchy as far as having actually done stuff. I've done a lot of sitting around in government offices and things this weekend, and I did go up to Mark's on Sunday and do some machining and stuff. I'm going to die if I keep talking. So thanks, guys. I'm out, and more soon. Hey, appreciate you watching. Be kind to each other.